Hi class. In this video what I want to do is I want to talk about the multiplication of monomials. So if you remember in the previous lecture we talked about what a monomial is. It's just a single term. So something like 5x or 12x cubed. Those things are monomials. So this lecture has two objectives. We want to talk about how you multiply monomials, and then what we finally want to do is simplify powers of monomials. So that would be something like 5x 5x squared, that raised to the fifth power, something like that. Okay, so first off, multiply monomials. So first, in the exponential expression x to the fifth power, x is what we call the base, and the 5 is the exponent. So the exponent indicates the number of times the base occurs as a factor. So for example, the product of an exponential expression with the same base can be simplified by writing each expression in factored form and writing the result with an exponent. So we'll start with something simple here. Suppose you have x cubed times x squared. Well, what is x cubed? X cubed is x multiplied by itself 3 times. What is x squared? X squared is x multiplied by itself twice. So this becomes x times x times x multiplied by x times x. Well, how many times do we see x? There are 5 factors here. So this is just x multiplied by itself 5 times, which we know is x to the fifth power. So what did you see happened here? Like, what did we do with the exponents of 3 and 2 here? Did you notice that 3 plus 2, very interestingly, gets us 5 here? So adding the exponents results in the same products. So x cubed times x squared is the same thing as x raised to the 3 plus 2. Well, 3 plus 2 is 5. So that gives us our first rule here. And this is rule for multiplying exponential expressions. If m and n are integers, and we have x to the m times m to the n. So the base is the same. Okay, this only works when the base is the same. This results in x raised to the m plus n power. So in each example below, we're going to multiply two exponential equations with this is important, the same base. So simplifying the expression just by adding the exponents. So if I have x to the fourth times x to the 7, the base is the same, so we just add 4 plus 7. This just simplifies to x to the 11th. If we have y times y to the 5th, well, when there's no exponent, there's really an invisible 1. So this just becomes y raised to the 1 plus 5, which just gets me y to the 6th. You can do this when you have more than 2. So a squared times a to the 6th times a. Well, the bases are all the same. So just add the exponents. This would be 2 plus 6 plus 1. 2 plus 6 plus 1. This just simplifies to a to the 9th power. All right, let's try a harder one here. Okay, let's try 2xy times 3x squared y. Well, what we can do here is we can rearrange the terms to put kind of like, think about it as like terms next to each other. So we can take the 2 and the 3, put that in parentheses as 2 times 3. X times x squared, let's put that next, and then finally y times y, so put that over here. So now just follow our simple rules. 2 times 3 gets me 6. X times x squared, well, that's 1 plus 2, that just gets me x to the third power. And then y times y, well, I can write that as y raised to the 1 plus 1, and that just gets me y squared. So this really crazy looking problem actually just simplifies into 6x cubed y squared. Okay, you can even skip around and skip these steps and just go like this. 2 times 3, boom, gets me 6. X times x squared, add the exponents, 1 plus 2 gets me 3. Y times y, that's just 1 plus 1 gets me y squared. All right, let's talk about how you simplify powers of monomials. Okay, so a power of monomial can be simplified by rewriting the expression in factored form and then using the rule of multiplication of exponents. Another way you can just do this, so rule for simplifying powers of exponential expressions. If you have m and n, all right, are integers, then if I have x raised to the m power, which to itself is raised to the n power, whenever you have a power to a power, you're just going to multiply. So x to the m raised to the n power is just x raised to the m times n. So each example below is a power of an exponential expression. So let's simplify the expression by multiplying the exponents. So for example, if I have x to the fifth power squared, well, that's a power to a power. You're just going to take 5 times 2. We know that that is 10. So this just becomes x to the 10th power. Here, if I have y cubed raised to the 4th power, multiply the exponents, just like you see in here, power to power, multiply. This becomes y raised to the 3 times 4th power. 3 times 4 is just 12, so this just simplifies as y to the 12th power. All right, another one here, a little bit harder. So suppose you have multiple things inside of parentheses, okay? So if you have the following m, n, and p are integers, okay? If I have x to the m times y to the n, and all of that raised to the p power, just distribute the p to each term here, or each product, or each factor, excuse me. So this becomes x m raised to the m times p, and y raised to the n times p. So just take this p and multiply it to each exponent. All right, so let's simplify the following down here. First, if I have c to the 5th power times d to the 3rd power, all of that raised to the 6th power, we'll just take the 6 and distribute it to each exponent. So this becomes c to the 5 times 6 and d to the 3 times 6. Well, 5 times 6, this gets me c to the 30th power, and d, 3 times 6, gets me d to the 18th power. All right, this one's a little bit harder, all right, because it has a coefficient here. So if I have 3a squared times b by itself, okay, b here, all of that cubed. Well, I'm going to distribute the 3 to every term, every part of this, every factor, including the coefficient 3. So this becomes 3 to the 1 times 3 power, a to the 2 times 3, and b to the 1 times 3. Well, 1 times 3 gets me 3 to the 3rd power. 2 times 3 gets me a to the 6th power. And b, 1 times 3 gets me to the 3rd power. The final step here is just taking 3 and raise it to the 3rd power. Well, what is 3 to the 3rd power? That's 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 gets me 27. So this final expression here simplifies to 27 a to the 6th b cubed. All right, let's end by doing this hard, crazy example here. So I have minus 2 times minus 3 times x times y squared, that quantity cubed. Okay, so you have to follow your order of operations first here. So before I can multiply here, I have to take care of this exponent here outside the parentheses of a 3. So what I have to do is I have to distribute this 3 to the minus 3 to the x to the y squared. So I'm going to leave this minus 2 alone for a second. So I'm going to have to figure out what minus 3 to the 3rd power is. X to the 3rd power I can just write as x cubed. And y squared to the 3rd power, so 2 times 3 gets me this 6 here. All right, so I have to simplify what does minus 3 cubed equal. Well, minus 3 times minus 3 is positive 9. Positive 9 times minus 3 gets me this minus 27. So next what I'm going to do is I'm going to take this expression and I'm going to multiply it now. So I'm going to take minus 2 and multiply it by minus 27. I'm going to write that here. And I need to take this x and multiply it by x cubed. Well, minus 2 times minus 27, negative, negative becomes a positive. So 2 times 27 gets me 54. And x times x cubed, well, remember here I'm going to add the exponents. So there's an invisible 1 here. So 1 plus 3 gets me x to the 4th. And this y to the 6th power, don't forget that that comes down. And my final answer here is 54x to the 4th, y to the 6th. All right, class, I hope that helped.